All right, let's go ahead and do the video. Um, I have a bunch of notes on the board. Didn't go super well, but that's all right. In this video, we're going to cover three things eventually. Kind of the atom, the structure of it, where things are in the atom, what their charges are. And then we're going to talk a little bit over here on this board. We'll talk about the number of protons and reading one of the symbols on the periodic chart. And then lastly, we'll talk about isotopes. So it's kind of a bunch of different things. But first off, it's really important for the core test and in this class also that you understand the basic idea of the atom and what it's made out of. The atom's made out of three distinct parts: the protons and neutrons, and then the electrons. And we have spent all year talking about this, so I hope this is an extremely easy review. If you look, you've got right here, looks like my camera's in my base crooked, so I'm all bent at it. So what we have, our protons and neutrons are relatively big. And when we say relatively, we mean they're extremely small, but they're way bigger than the electron. The electron, in fact, is 1/2000th the size of the protons and neutrons. Now, you need to know inside our atoms, we have the nucleus, and inside the nucleus we have protons and neutrons. This example is of helium because it has 2 protons and 2 neutrons, which have essentially no charge. All right, so understand this. Protons and neutrons are in the nucleus of the atom, and on the outside, and this is not the right, correct model, but it's good enough, outside of the nucleus are the electrons. Now, you down here for atom. We spent a good deal of time talking about that in part A, but it's made out of mostly empty space. The distance from here to here is a massive amount of distance. And I'm making this up, but it's relative to, say, if we had a marble at the center of the football field, then the electron would be about where my classroom is from the center of the football field. So yards and yards, maybe 200 yards. And in between that would be nothing, which would mean it's mostly empty space. All right, let's get to this little part here. Make sure that you know the properties of the 3 particles. The proton, that means positive. It has a positive charge. Neutron is neutral. All right, shouldn't be too hard. And then electron is the only one that doesn't make perfect sense, but we've electron 1,000 times. The electron is a negatively charged particle. So when an atom loses an electron, it becomes a positively charged atom overall. All right, so make sure that you know these. Make sure to remember that the electron is very small compared to the proton and neutron. Make sure you remember the atom over here is mostly empty space. Make sure you remember that the protons and neutrons live in the nucleus and the electrons live outside. All right, let's move to this slice. So what we have over here, this one won't be as easy to see. All right. We said this 1,000 times in class, but I just wanted to make sure we review. The number of protons in an atom determines the identity of the atom. Everything else can change, but protons can't. If I change protons, I'm changing who I'm talking about. It's as simple as that. So make sure you understand protons determine what atom we're talking about. So if you look over here at this chemical symbol for Na, let me move over a little bit, you'll see that we have Na and then 2 numbers, 23 and 11. The 11 is what we call the atomic number. This is annoying. It's the atomic number which is equal to the number of protons. So if I change this number, I'm changing the number of protons, and I'm also changing the identity of what I'm talking about. And in chemistry, we don't do that. We can change electrons, we can change neutrons, but in chemistry, we never change protons. That would be a nuclear reaction. and we do chemical reactions in chemistry. All right, make sure, smaller number, protons. Bigger number, atomic mass, and that comes from adding protons and neutrons. So if you ever ask for neutrons, it's just the difference between the two numbers. So sodium would have 12 neutrons because it's its mass minus its number of protons. Okay, make sure you know which of these numbers are which, what they mean and what they don't. Do not get them backwards, please. All right, now last little nugget. We'll come over a little bit here. The last thing we're going to talk about are isotopes. Now, an isotope, let me get this all situated. Bring this back over here. Okay, an isotope is simply an element with different numbers of neutrons. It's the only thing we can mess with. And I'm more tilted, I can see in the camera. I apologize, I'm over it. Okay, so isotopes, we are going to be talking about the same element, but we're going to change the number of neutrons, and that is represented by writing different masses. So on the periodic table, carbon would be 6 and 12. The 12 would be the mass of the most common isotope of carbon. So we'd write carbon and then a 12. Well, carbon-14 is also carbon because it still has 6 protons, but I've changed the number of neutrons here. By changing the number of neutrons, that affects the mass of what I'm talking about. So we just write isotopes with an additional mass number. All right. Please be careful on these. They will try to trick you up. Isotopes mess with the neutrons. Ions, in a whole different lab book we did, ions come when we change the number of electrons we have, which changes the charge of the overall substance. All right, hopefully that will help.